Welcome to all of you watching us from wherever you are. Welcome to Renault E-Ways, a unique event dedicated to the mobility of today and tomorrow that gathers the men and the women who are taking tangible actions to meet the challenges towards zero emissions. This is a live broadcast. We're here today from Hangar Y, which is in Meudon, just outside of Paris. And with me on stage today, I have Christophe Dudezert, Energy Service Program Manager at Groupe Renault. Nice to see you. How are you doing?
Thank you. Fine. Thank you.
Great. Yannick Jacquemart is with us also, Power System Economics Director for RTE. You'll tell us a little bit about what you do later on. How are you, Yannick? Is everything good?
Pretty fine.
Fantastic. And connected with us from Newcastle upon Tyne in the UK, we have a fellow Brit, Matthew Lumsden, founder and Chief Executive Officer of Connected Energy. Matthew, how are you? Can you hear us? We'll see Matthew a little bit later on. No worries, he'll be connected with us, yes. So to face climate change, one of the major environmental issues we have to address today is to increase carbon-free electricity production, a challenge that electric mobility and batteries could help meet, thanks to stationary energy storage, a solution that we're here to discuss today. So to start with, I think we should get back down to basics and maybe explain what stationary energy storage is. Christophe.
Okay, thank you for this question. So actually, a stationary system can be seen as a buffer. Mm-hmm. So you put it between a producer and a consumer. So a producer, you can take it as a solar panel. Sorry. Yeah. And when you consider solar panel, it's an intermittent producer. So you don't know exactly when and how much energy we produce. So concretely, seen by the grid, it's a kind of burden. It's complicated to manage. So you need some buffer, so stationary system can help, and basically it compensates the gap between this production, this too much energy, and the consumer, you and me, that is consuming in-house and so on. So that's the basic principle. So it is designed mainly to improve and increase this renewable energy implementation and energy mix in the future. So more and more we are expecting having such kind of devices.
Fantastic. Can you tell us why car manufacturers are embarking on stationary storage with batteries, Christophe?
Yeah, okay. I can see that it can be strange at the beginning to think about that, but actually it's kind of logic. 8 years ago, we launched the adventure of EV for Renault. And at that time, we have seen that our design and the batteries we have are much more than only mobility tools, actually.
Right, yeah.
So we consider that embodied in the car, you have a battery that is fulfilling many, many things. And after the, let's say, adventure inside the car, we believe that there is a residual value for the battery that is huge. And this value can be used for other systems, much less stressful than vehicle, because vehicle is a kind of, let's say, nightmare for a battery. You have a lot of things happening to batteries. And
how is it a nightmare? Just tell us how it is a nightmare.
I mean, you have, when you design a battery, actually, you design something that is able to fulfill strong conditions. You have vibration, you have thermal behavior that you need to manage. You have, let's say, hard condition in terms of state of charge and so on. So charging, discharging, every time. Mm-hmm. So actually, they are very strong, these batteries. And our engineers made a great job. And what we observe now is that, technically speaking, you can do much more after and integrate it into stationary system. It's logic and it make a lot of sense. So that's the first part of the answer. The second one is that regarding ecosystem and circular economy,
sure,
we have to make it happen because we have to extend the life of the battery as much as it can, and we consider that after its first life, you have the possibility to do. So we are doing actually.
Okay. Just to be clear, how is it actually, what does it physically look like? Is it like in a box, in a container?
So it depends always, and so unfortunately you have no generic question, but what we observe currently is that you can put a stationary system with a kind of large scale, so 1 megawatt scale, it's kind of big scale. You can consider that you can put in between 30 to 50 batteries in a container, and it's a kind of...
More like big containers that you put on ships kind of thing?
Exactly, yeah. 14-feet container, actually, what we experience. And you put it in the on shelves, so you have a lot of battery on shelves, you connect it with a lot of power devices, and then you connect to the grid. And that's where the other partner like RTE happen.
He's going to tell us about that in a little while. Just another question for you, Christophe. We also hear about stationary storage for self-consumption. Is that something you also work on?
Yeah, obviously. So we are actually from 3 years now, we are experiencing a lot of projects. We even put batteries on boats. So we experience a lot of things, especially for these second life battery. But actually, we are in a period where we need to prioritize. We have actually not so much battery for second life today. We started the adventure of EVs 8 years ago. So actually, our batteries are very good in vehicles, so they are not dead and not yet to be dead, actually. And so it means that we have low volumes. What we are pushing on is more on large scale let's say, projects, and that's why we are involved with Connected Energy, with other partners for stationary system.
We're going to hear from Matthew in a few minutes about Connected Energy and your partnership. Yannick, it's over to you now. Before we get down to business, we start discussing in detail your opinion on this battery for energy storage. First of all, can you tell us what your job consists of and what you guys do exactly?
So, thank you. So RTE is the French TSO, so Transmission System Operator, which is a big name to say. What we operate is the main electrical grid. And what is important for today's discussion is to understand that it's a kind of a sharing platform, energy sharing platform throughout Europe. Wherever you connect, the energy can go instantly from one place to anywhere else in Europe. So it's a platform to connect all this and to come to the batteries. If you have a battery, then if it produces energy, you can serve a customer which is far from this place. This is just to understand. Our job is to maintain the lines which enable this, but also to develop all the services and the markets which allow operators, customers, generators, and now storage to come into play and to interact and to find the best equilibrium and enable any customer in Europe to get the electricity as cheap as possible.
Fantastic. So it's very interesting that you're with us today. Can you tell us what you think about battery for energy storage, first of all, Yannick?
So batteries are new items, new devices, and we are carrying out many experiences to integrate them into the service, into what makes the system work better. As a TSO, we are technology neutral. Sorry, we cannot favorite one generation means or batteries or customers, but we try to integrate all these and find out what are the best business cases and the best conditions to offer to the operators to come into play and to offer their services. Batteries for the moment are used for what we call frequency control, which is something sounds technical, is the electricity frequency that you have to maintain. What is magic with electricity is that you cannot store it. Now we just start, but mainly all the consumption has to be fed in generation at the very second.
Right.
So each second when you switch on the light, somewhere in Europe, someone starts something to produce this electricity. This is the magic of it. But then we need to have some automatic control, of course, to carry this out. And batteries, which are very fast, this is the main feature which is of interest for us. They are very fast, they can consume, they can produce, so it's a fantastic tool to enable and improve this control.
So the advantages are being rapid, I guess. Is that the major advantage of batteries?
Yeah.
What are the disadvantages?
The disadvantage is the size, because 1 megawatt seems pretty much for you, but for us, this is very small.
Sure.
And the amount of energy, even if you have the power, 1 megawatt is a power, the amount of energy you can store is limited. So you can not have it more than a few minutes, maybe an hour, maybe 2 hours, but not more. Whereas we are used to work with generation units like coal, gas, renewables, of course, nuclear and so on. They all work all day round.
So this is a solution amongst others as well, of course.
Sure, so it has advantages.
Yeah.
It has also disadvantages. So we have to find together the right place. And my job, what you were asking to me, my job as a Power System Economics Director is with my teams, of course, to design the market rules which enable all devices to come into play and to find the best solution and the best business case for them.
Fantastic. I'm going to head over to Matthew now, who's coming to us from Newcastle on Tyne. You are the founder and chief executive officer of Connected Energy. Connected Energy has commissioned its largest ever second battery life energy storage system, the e-store, if I understand well. Please tell us all that we need to know, I suppose, about this solution, Matthew. And perhaps the first question, why are you working with Renault's second life batteries?
Okay, so I guess thanks for the introduction and why are we working with Renault? I think as Christophe identified earlier, we're right at the beginning of this journey. And to be successful, we've got to sort of think strategically about the long-term opportunity of second life battery and the sustainability benefits, etc. But also in the short term, when there's relatively small quantities of batteries available, we've got to sort of take tactical steps to sort of achieve our goals and you know, walk from stepping stone to stepping stone. So what's been really good with Renault is that we've got a really strong partnership which enables us to collaborate and work together in a really open basis so that we can match the number of batteries that are available with the projects that we have in our pipeline. I mean, the other side of it, I guess, is the batteries specifically. And again, you know, Renault are quite unique in having really good visibility on how many batteries will be available when and what the quality is of those batteries. And obviously, when we're selling systems on to our customers, we need to know when the batteries will be available and how much capacity is available in them so that we can make sure the systems meet with customers' requirements. If we talk specifically about our systems, then you've obviously hit on the fact that a lot of these systems are containerized. So if you imagine a shipping container, we have systems that are smaller systems that have half the container filled with batteries and half with power electronics. And then we have much bigger systems which are sort of in H clusters with a central power control container and 4 container loads of batteries around them. And you know, the key thing about second life batteries is they're all slightly different and they're all designed to operate in electric vehicles. So what we do is understand through our control system exactly what the state of health is of all those batteries and operate tens or hundreds of batteries all as one system so that they respond individually to provide an aggregated amount of power when required.
Fantastic. In addition to the e-store product, Matthew, Connected Energy is providing other energy storage technologies and services. Can you tell us about them as well, please?
Yeah, so I mean, we're really interested on the role that energy storage plays in the grid generally. And we're working on a really big project in the south of the UK, which will really start installing kit next year, which is a local energy system. And that's about understanding how energy storage in the form of second life batteries and also in domestic energy storage, but also utilising electric vehicles and PV and EV chargers, how you can operate all of those as one big system to provide local benefits. So that's about improving air quality, improving the carbon intensity of the energy that's used, and reducing the cost of energy. So we'll be installing systems in commercial sites, in domestic properties, etc., and really trying to understand what the local energy system of the future will look like. And this is one of 4 large-scale demonstrator projects in the UK.
Thank you very much, Matthew. Christophe, compared to European neighbours, is France positioned well on the large-scale stockage markets?
So it's a question for me, but also for Yannick, I guess. So in terms of stationary system, we are starting, to be honest, in France. I guess that more and more stationary systems are introduced because the rules are coming, and then the, let's say, the technical definition is more and more clear. But we also have large progress in Germany, where the dispatching of energy is a real constraint due to, let's say, some political reasons. So actually, for these 2 countries, yeah, the things are improving much. UK is also a very interesting country, but it's insulated country, so other, let's say, technical constraints and so on.
Of course. Yannick, what can you complete on this subject?
Yeah, France is not the best place because of the economy of the electricity in France and the fact that there are less constraints as in other countries like Germany and so on. So for the moment, it is a little bit less developed.
Yeah.
But it will be everywhere, so it will be also in France. What we are doing is, in our vision, is preparing the future. For the moment, batteries are quite useful, as I mentioned, for frequency control. We will start next year some experiments on congestion management. That means when a line in the network is overflowed or congested, then maybe if we have a local battery, we can use it to store the electricity at that moment, which is overproduced maybe. And then you release it later on. So the economy of it in France for the moment is not so good. The business case is not there for yet, but we are sure it will be here in a few years. So we have a plan to get ready. We want to be storage ready for everything, and we will see when the business case comes. But it will come later than in some other countries due to the price of electricity mainly.
I'm curious, how long have we been stocking energy in batteries? Is this a new technique?
So actually, it's kind of similar of what happens in a vehicle, actually. You store it exactly the same way, but at a larger scale. So in vehicle, you have a charger on board, and you use it to store energy inside the vehicle, and then the energy transformed to kinetic energy, then to move the car. But here in stationary system, it's kind of similar things. The only thing that the energy, so electricity, is injected in the grid directly. So technology is not so far from it. It's just larger scale.
Just larger scale, of course. And it's existed for the last, since the electric cars have been existing, is that correct?
So
storage.
Storage, yes. You have different forms for storing energy. You can not only use batteries, you can also use other devices like hydropower plant or any kind of other, let's say, technologies that can store energy, literally. But, you know, the expansion of, let's say, electrochemical energy storage system, like battery-based storage system, is developing since 10 years. It's mainly due to the lithium-ion technology development around all the fields.
And so we have room for improvement. Is there ways that we can improve this technique, Yannick?
Yeah, storage is one of the fields where the improvement is the most important. Maybe with solar PVs that everybody has seen, and wind farms for electricity also, and now the offshore, which is impressive. But storage, you see it everywhere. You see it in your phone. I mean, you see the size of your phone. You just compare it with the one 10 years ago, and you just have the clue, because it makes 1,000 things more, and it's 10 times less heavy.
That's it.
I think it's the same for the cars. It's the same for any storage. So that's the reason why I was saying we see the decrease in cost, we see the increase in efficiency. So we know it's a solution for the future. And even if it's not mature yet for any applications, we are looking for all of them and get ready for all of them, because it will come. It will be one piece of the puzzle.
Perhaps one additional comment. The fact that Stationary system based on container, let's say, shape is very convenient to locate it where you want. A hydropower plant, you cannot move it. It's where water is. Stationary system, especially for congestion management, where the issue happens, you can be there. So that's the purpose.
It's mobile. Are you working on other technologies, Christophe? Other solutions?
Yeah, actually, we have, as I said before, we have extended portfolio of storage solutions, but one very interesting project we have currently is one we will commercialize this year, located in our plant, actually in Douai plant, where the future EV vehicle will be produced. And it's a kind of large scale, what we can call large scale, even if it's small for you. For us, it's a big, large scale project. It's 5 megawatts, so it's around 4.5, even more megawatt hours. So concretely speaking, for you, it's 150 batteries we put there in container. We connect to the grid, and what we are doing, or what we want to start, is a commercialization to the flexibility market. So exactly the markets mentioned by Yannick before, regarding filling the gap between production and consumer, but in real time.
Fantastic. I think we're coming to the end of our discussion, but I know that if you have your questions, please send them through. Keep sending them through to us, because we're going on to a question and answer session with all three of our experts here today. So yeah, we have some questions already come through. Let's get started with our Q&A session. What are the main differences between the two projects you presented today, advanced battery storage and smart hubs? Christophe, that's for you, I think.
I can start with this one. So. Yeah, advanced battery storage is, I forgot to name it, but it's the name of the famous project we plan to commercialize this year. So it's a 5 megawatt container we put in our plant. The main, I would say that they are very similar, to be honest, in terms of technical. The purpose is very similar. The design is based on two different technologies. Today, in our let's say, advanced battery project, we are based on Douai batteries. So it's kind of, let's say, a very specific battery. And in UK project, they are based on other vehicle batteries, so Kangoo, and so I think that the first difference is that, if I can say, technically speaking. Then the other thing, is perhaps the specificity of the grid market over there. It's not really the same between France, or Germany, or UK, but perhaps Matthew can tell more about that.
Yeah, Matthew, over to you. You have any comments?
So yeah, they are similar. I mean, our system's a bit bigger, so it'll be about 14.5 megawatt hours. So that's about 1,000 Renault Kangoo batteries. And I think the key thing, as I sort of mentioned before, is that we'll be providing these frequency services to the grid in the short term, and then probably it'll be used for other mechanisms, so perhaps energy trading in the longer term. But importantly, it's part of this local energy system, so it fits alongside some other systems. So we'll be installing about 10 300 kilowatt systems as well on industrial and commercial sites, and there'll be domestic energy storage in there as well. So we're really interested in how do you operate all of these different systems together, along with EV charging as well, to create more value than the sum of the parts. So it's very much a system demonstration type project.
Thank you, Matthew. We'll move on to a second question. It's for you now, Yannick. What are the pros and cons of battery-based storage systems compared to other solutions?
So I can develop a little bit. So compared to other solutions, other known solutions like hydro, which was mentioned by Christophe, hydro is very long-term storage. It can be used for seasonal, and we use it in France, for instance. We store the water during spring and so on, and we can use it in the winter, or now, maybe if it's cold and so on, we can use the water that we stored before. For batteries, this is not the case. Of course, you will not store from one season to another. It's nonsense. It's only a few hours, but it's very fast. So a few hours you can use it, for instance, as a complement for solar PVs. If you say from noon to 3 p.m., then maybe there is pretty much generation, maybe too much in some areas. And then you can store it and you release it in the evening at 6 or 7 p.m. when it's more needed and when electricity prices are higher. This is one news. For the moment, this one is not very, the case is not so good, at least in France for the moment, but it is the case in other countries, of course, in US, in Chile, and and other places. And the second point was the one that was mentioned, it's pretty fast. And for instance, we have currently, and for some years, some problems with the frequency at very precise moments. We know it's at 9 p.m., 10 p.m., 11 p.m. We know this. But we do not have the opportunity to say to a nuclear power plant, you should change for 1 minute or 2 minutes your generation, and then we will come back later on. I mean, we do it a little bit, but not so much. Now with batteries, we can, as a market designer, I can invent some products, some ways of remunerating these batteries, which will be able to answer this. For them, it will be balanced over half an hour, but maybe they can consume the first quarter and then can generate the second quarter. For me, it's very fine, for them also. And this is a new product adapted to the new capabilities of these devices.
Great, thanks, Yannick. Moving on, this is a question for you, Matthew. Why did you choose second life batteries instead of new batteries?
Because we're masochists, I think. So we're just really interested in the sustainability piece around this. Of course. And you know, if we can give second life batteries another 7 to 10 years of use, then we're effectively doubling the value that's been extracted from the resources that have been put into the construction, design, and development of those batteries. Obviously that has a potentially enormous impact on the on the impact that the growth of electric vehicles will have, etc. And also they have a second implication, which if you're able to encourage the proliferation of energy storage, then that in turn enables the easier integration of renewable energy onto the grid, which wind and PV are difficult to control unless you've got something like energy storage to support that. So it feels like a double win really, in that you're getting more value out of those batteries and also facilitating greater penetration of renewable energy.
Thank you, Matthew. Moving on now, a question for you, Yannick. What are the energy production targets from renewable energies in Europe? Is the increasing amount of renewables a problem for electricity management?
Very wide question.
Yes.
The targets are tremendous. They are changing, but always increasing. So, as you may know, the main policy of the new European Commission is called the Green Deal. And with the Green Deal comes a new law on climate, which is currently debated. And the idea is to go as far as 55% of renewable energy in 2030. That means it's less than 10 years now, nearly 9 years, quite close. And maybe they want 60%. So it's tremendous. And in my division, we're currently working on a report which we will release, I guess, by the end of November, come on with the International Energy Agency, about is it feasible to go to 100% of renewables, and what kind of problems would it cause? So I like pretty much the question. What I can answer is not the full report, but in a nutshell, it's possible if it has some conditions, but it's not impossible. It has some conditions, and batteries is one of the keys that can help. We will need storage at different time scales, as I tried to explain. Hydrogen will be also one solution, but batteries also. And of course, e-mobility will be very important. And the way of charging the vehicles is very important for us, because if everybody charges his vehicle when coming back at home at 7 p.m., then it's a nightmare. It's another one nightmare, ours. And so the ways of managing the consumption, the charging, of having all the devices on fully changes the way of operating the system. So our job will be changing in the next decades as much as it has been changing at the beginning of the 20th century. So this is for us a genuine revolution, but we're working on it, and it's really fascinating.
Perhaps one word, sorry, from OEM, so from Renault. We try to help actually in that concerns, and what you call, smart charging, the way to charge when it's better, not really for let's say for driving, but for the grid, knowing that the customer will be anyway served for energy, for sure, that's mandatory. So we are developing this smart charging. So we already experience it in Netherlands, so it's coming. And in the gene of our vehicle, we will have anyway in the coming decades. So you will have some help from us, and we won't even go. Let's say we plan to go even let's say higher. I would say by using vehicle as also a kind of producer. It's also a possibility to reverse, not only be able to charge, but also to discharge into the grid. And that's a project we are strongly working on.
Fantastic. We have more questions, of course, coming in. We have about 5 minutes left. I think, Matthew, if you want to complete on any of the answers here, just give us a wave and I'll come to see you. I mean, you can't, it's difficult for you because you're at the distance, so give us a wave if you'd like to complete something. This is a question for Renault. Do you plan to propose stationary stockage solutions for residential houses like Tesla do?
Actually, we did. We already have some, let's say, experiment or project in UK for such kind of home device with power volt. So actually, we know that our battery are able to do. So that's the first thing, and that's the first thing we wanted to know. To be honest, in the past few years, we decided to go more on focus on larger scale projects like stationary systems. The home, let's say, home device can be, in our vision in the future, also fulfilled by vehicle directly. Why not using your vehicle when it's plugged at home to fulfill your home needs? So actually, that's more our spirit currently.
Okay, question for Connected Energy. Matthew, it's over to you. Do you work with other manufacturers than Renault? Are there any differences in their approach?
We do, yeah. We work with a few. So differences in approach. I mean, the batteries are different. So there's always, when we developed our system, we developed it specifically so that we could control different types of battery as they became available. In terms of the approach, then I guess as I mentioned earlier, a distinguishing feature of Renault from our experience is just this ability to work on the short-term issues to achieve a long-term goal. And I think it's been quite a powerful partnership in terms of trying to achieve these first steps, I guess. But a lot of OEMs are looking at this, but I think you've already heard the scale of what Renault are sort of achieving at the moment, and I think that's pretty unique.
Yes, thank you, Matthew. We have a question to maybe, is this the last question? You can let me know in backstage if it is. Question for all of you. Can Second Life batteries be powering street lights? I like this question. Who would like to answer first? We have a little bit more time, so who would like to answer first?
Okay, I can try first, but it's not very satisfying answer I will make. No, it's obviously there is no technical blocking point to make it. It's just a question of sizing. So you need also to have enough energy to fulfill street lights for a long, all night long. So, but there is no constraint for that. I mean, it's a kind of low power application. Basically, not so much energy you need to to light streets. So I would say you can do it. It's a question of sizing.
I didn't study technically, but I guess you can with the limit of the duration. As I mentioned, the main drawback is that you do not have this power for a long time.
Yes.
But you can have a light for the evening, for sure. The main question is it the best use of these batteries?
Sure.
Is it more affordable than being connected directly? And it depends. If you have a municipality which owns some vehicles and has the batteries, maybe it's interesting for them just to use them, but it will be case by case.
Okay. We have time for a couple more questions. This is a question for whoever would like to answer, really. When will it be financially sustainable to buy a battery storage for your private home with solar panels? And does a normal family house have a sufficient roof surface to be equipped with solar panels to get 15 kilowatts electricity? Who? Yannick?
I will try some elements at least. The first question is something I would answer no, but I know it's a trend, but where you're connected to a grid, my feeling, my understanding from the economy of electricity and even as a citizen, and even for sustainability, I would really prefer to have all these batteries and PV panels and so on, connected. Why? Because I think this is what we call the economy of sharing. You see, for the cars, people tend to say, I will not own a car, I will share it, I will lend it, and so on. And it's less investment, it's less material, and so on. For electricity, we always have shared. No one has his power plant. You are connected to a platform which links you to any kind of plants. So the same, if you have a battery, if you invest in it, you get revenues from it, no problem, but share it, I think it will be better, because if any of us get a battery, get a PV panel or whatever, then you will have more investment, you will have oversizing, more materials, recycling problems, and so on. So my opinion is really that we need better to develop a sharing platform and share everything. So buy, invest what you want. We will try to make it remunerated, of course, but connected. But I'm sorry, I forgot the second question then.
Go back to it. Does a normal family house have a sufficient roof surface to be equipped with solar panels to get 15 kilowatts electricity?
15 kilowatts is more than the needs of a normal family, I must say. Most customers have 6 or 9 or maybe 12 sometimes kilowatts. So if you have a very big house, maybe you can, but this is quite a surface. So most, as far as I know, most domestic plants are 3 or 6 kilowatts rather than 15. So I guess I do not have the figure, but I guess this is quite a surface.
Christophe.
Just perhaps one comment on the first one. You mentioned sharing of, let's say, devices like solar panel and so on. I think that one other way is also to store where you produce. So if you mentioned the infrastructure impact when you want to install a storage system, solar panel, and so on. The idea in the future, if we can use the vehicle to make it directly, so to store the battery, to store the energy produced by solar panel, you do not add something, you do not add constraints for the grid. You just use as it is and you help it. So I think that's a good way to take the issue and to improve.
Okay, Matthew wants to speak. He raised his hand. We can see him. Matthew, over to you.
So this is something that we're working on in our Smart Hubs project. So we'll be installing domestic energy storage and PV on quite a few homes, private homes, and also potentially housing association properties. And those will be all linked into the virtual power plant, which will be operated by a company called Moixa. And we're really interested in exploring whether we can aggregate all of those domestic energy storage systems to provide an equivalent flexibility service to the grid that we've talked about in relation to large energy storage systems. So it's exactly what you've just been describing. It's about sharing that embedded resource within the system and see if we can create some more than the sum of the parts and value for the whole system itself.
Fantastic. I think we're coming to the end of our question and answer session. I had a timer that sort of appeared, and we're running out of time. The discussion was passionate. Thanks so much. I've got so much information. I feel like I've learned so much with you guys today. Thank you so much, and I'm sure you watching have enjoyed time with our experts. Yannick, thank you so much. Christophe.
Thank you very much.
Matthew, I hope everything's okay in the UK. I believe it's a bit complicated at the moment. As a fellow Brit, I'm thinking of you. And goodbye and good luck to all of you for the future of this fabulous solution. If you want to find our information, you can go on our website, of course, and get all the information you need from this talk. And I will see you again very, very soon. Thank you so much.
Thank you.
Thank you.
Goodbye.
Bye.
Bye.